I'm writing a chess program for my Kindle in Common Lisp. Where we left off last week, we could render a board with some pieces on it and move the pieces around by clicking. My goals for this week were improve my feedback loop, probably involving some unit tests, fix a couple of bugs, and get the thing running on my Kindle. So how's that going? Not well. Let's start with the good stuff. I wrote some basic unit tests. The book that I'm reading has you write a unit test library. It's super simple and basic, but if I need to make improvements, I can. Last week I noticed this bug where when I captured a piece, the piece would change colors. Interestingly, the unit test that I made for this did not fail. The state is apparently being updated correctly. In practice though, the old value was still there, and so when I was rendering everything, I would render the white piece and then render the black piece in the same spot. And then it was time to try to build the thing so that I could actually run it on my Kindle. When you build a program, you are translating it from the code into a binary, which is effectively just a sequence of instructions for your processor to execute. The language that a processor speaks may be different from processor to processor, and especially from architecture to architecture. So, for example, my computer is a AMD 64 architecture, but the Kindle is ARM. Using a computer with one architecture to build binaries that run on a different architecture is called cross-compilation. Some tools do this really well. Common Lisp seems to not. Because Common Lisp is sort of its own highly stateful interactive execution environment, the way that you would get a binary built for a specific architecture in that is to build a Lisp environment first, so SBCL is what I'm using, and then load the program into that and then dump it to an executable. But of course, my computer isn't ARM, it's not the same architecture as Kindle, so how can I get a running Lisp environment for my Kindle running on my computer? Let's talk about Docker. Docker is a tool that lets you create containers. You can kind of think of it like emulating a specific environment. Basically, we can have a Docker image that is effectively emulating the Kindle's architecture, and we can do things in that. So the goal was get SBCL running inside a Docker image that's the correct architecture, and then we can build binaries in there that will hopefully run on the Kindle. Did that work? No. So I was able to use a Docker image of that architecture, ran SBCL inside there, and was able to get a binary for ARM. So I copied that over to my Kindle and ran it, and it crashed. Let's talk about static and dynamic linking. When you build a program that depends on other things or has dependencies, you can choose how you want the actual binary that is built to reference those dependencies. One way is to just include those dependencies in the binary itself. This results in a much bigger executable and also takes more memory to run. There are other disadvantages of static binding, but one advantage of it is you just get a, big pile of ones and zeros that if you put it on a computer with that architecture, it will be able to run it. Dynamic linking is when you expect that this specific dependency is somewhere on the machine that I'm running on, and I'm not going to include it in the binary. That dependency damn well better be on the system. The version of glibc that is on my Kindle, it's really, really old. And of course, the version on my computer is much newer, and so if I build against one and then put it on a system with the much older version, it's not going to run. Let's talk about Nix. Nix is a package manager that lets you produce deterministic builds. You just define everything you need in one file, and it goes and installs all of those and creates an environment for you that builds the exact same thing every time, deterministically. Unfortunately, I ran into an issue here, and I don't really know enough about Nix to figure it out. There's multiple paths forward, and all of them are going to be pretty jank. Option 1. Actually learn Nix properly and try to figure out why I couldn't cross-compile SBCL using Nix. I have enough friends that are staunch advocates of Nix that I may be able to nerd snipe them with this video into helping me figure that shit out. Option 2, somebody online actually figured out how to modify SBCL to allow it to create static binaries. We could just build one huge static binary with everything, glibc, GTK, all the stuff I need, and put that on the Kindle. We would, of course, just have to pray that the resulting executable is still small enough to fit into the limited memory that I have. As I was procrastinating making this video, I posted in the Kindle modding community's Discord. Someone had the idea that maybe should have been obvious to me of chrooting into a Kindle environment. Chrooting means change root, so you effectively trick the terminal into thinking that you are now in a different operating system. Thank you, wise Mistress Ella. Turns out consulting with the community of people that actually know what they're talking about is a really good idea. In any case, the goal for this week, get the damn thing running on Kindle. The learning continues. If you have questions, compliments, concerns, criticisms, I want to hear it. Comment below, and I will see you next time.